Hey guys, today we're going to be looking at various different data types and giving some examples for how you might apply them. We can define a data type with two features. Firstly, what values they can take, and secondly, the operations that we can perform on them. In some cases, we might have a piece of data that we want to store, such as a number, where there's more than one data type that we could use to store it. In this case, we want to make sure that we use the most memory efficient type so that we're not wasting resources. We'll go into some examples a bit later in the video to demonstrate this. We're going to make a start with integer values. These are whole numbers, so the number doesn't have a decimal place, and they can either be positive or negative and include 0. So for example, 105, 5,663, negative 2,045 and 0 are all integer numbers. The range of numbers this data type can hold is dependent on the language, and different languages provide different variations of the integer type. For example, most languages including C#, Java and C++ have a range of the numbers seen on screen for their standard 32-bit integer. If you wanted to store a larger value, in most languages there are the means to do this. For example, in C# you might use a long, which is a 64-bit integer, which can store between the numbers seen on screen now. As I mentioned earlier, choosing the most memory efficient type is important, so if I wanted to store something like someone's age for example, I'm not going to need a massive number like can be held in a long. It would be much better to use a smaller integer data type. I've included in the description some links to places where you can find out exactly what values and variations of the integer types a few different languages have, including Java and C#. Unlike integer types, reals, which can also be called floats in some languages, can contain decimal numbers. These can either be positive or negative and include 0. So for example, 10.6, negative 501.2, negative 1.2 and 15 can all be represented as floats. Now you might be thinking, well, hang on a minute, 15 is a whole number, why is it a float and not an integer? The important thing to remember is that a float can have a decimal, it doesn't have to. Let's say we're using this float to represent the weight of a bag of sugar. If we take a spoonful out, the value might need to change to 14.9, so in this case using a float was appropriate, whereas for example, if we were storing someone's age in years, it would only ever need to be a whole number, and so an integer type would be more suitable. Next up, let's take a look at Boolean values. A Boolean type can only contain one of two possible values, either true or false. If for example, we were creating an online purchasing system, we might use a Boolean value to denote whether the customer has paid or not. For those individuals interested in learning more about Booleans and how you can use them, I've linked a video in the description where I cover Boolean operations and go into further detail about this data type. Characters, often referred to as chars, are a data type that can only hold a single number, letter or symbol. So for example, if you wanted to store a person's satisfaction on a scale of 1 to 5, a char might be perfectly suited to hold the result as it uses very little memory and it's only going to need to store one character of information. Moving on from the char, the next thing we're going to take a look at is a string. A string is a collection of characters, meaning it can still hold numbers, letters and symbols. Strings can be used for things like holding names or forming questions. Now as I said, you can hold numbers in a string, but there are many reasons why you might not want to do it. Let's say I want to represent someone's age, in this case 24. I could hold it as a string, but what happens if I want to do an add 1 operation to it when they get a year older? Well, I just can't do that as a string, as it's just a collection of characters, but with an integer representation, I can perform all the operations on it that I could ever need. It's also the case that generally speaking, strings take up more memory than integers, which is also something else worth considering. Date time is a way of storing, well, as I'm sure you guessed, a point in time. There are loads of different ways that you can hold date time. For example, in SQL and .NET, date time is usually represented first with the year, then the month, then the day, and then for the time it's the time in hours, minutes and seconds. But different languages have different standards, so it's worth doing a bit of digging to find out how the language you're using operates. In the description, I've linked Microsoft's SQL documentation on datetime for those who want to see a couple of different variations on this type. Next up, we have records. Records are a way of storing a collection of fields, each of which can have a different data type. Think of it like a row in a database. For example, if let's say we're creating a database to hold information on people, one row might represent information relating to one person, such as their first and last names, their age and their email. In this case, their first and last names and their email are all strings, but age is an integer value. This can be useful when we want to group together attributes that have different types. Arrays are similar to records in that they can hold more than one value. Arrays have a finite length and contain a set of index values that all have the same data type. For example, let's say we want to create a set of related integer numbers. In Java and C# it might look something like this, but it does depend on the language, though an array is most commonly denoted with those square brackets. It's important to keep in mind that the index of a first element in an array is 0 rather than 1, so in this case the index values are 0, 1, 2, 3 and 4, and we can use these to access elements within the array. Let's say I wanted to get the value 4 out of this array. Now I know that it's at position 2, so I can simply use this as the index value and access it from the array like this. User-defined data types are much like the records in the database. They allow a programmer to create a customized data structure with different data types to be as memory efficient as possible. Going back to the person example we used earlier, we do much the same thing here. In C#, we would call this user-defined type a struct, but obviously this varies depending on the language. It's important that you know how to use them in your chosen language, so it's worth doing a bit of digging online to find out how everything works. So that wraps things up for this video. Of course, there are plenty of other data types out there, but we've covered some of the main ones you're likely to come across. We hope you found it useful. Thanks for listening.